Hi, my name is Nathan, and today we'll be going over complex numbers. Let's get down to business. Complex numbers. Okay, so here's the basic concepts of complex numbers. So primarily we'll be talking about the imaginary unit I, and I will equal the square root of -1. So if we square that, I squared will equal -1 because this square root squared will just equal that. Okay, so with these complex numbers, if a and b are real numbers, any form of a plus b, a plus bi, with a plus bi being the standard form, would be a complex number. So if a and b are real numbers and it has I in it, it'll be a complex number. And a, in this case, will be a real number, and bi would be the imaginary part. Okay, next up, we'll go over some of these rules. If b equals 0, so that'll just leave us with a. That'll just leave us with a, and because b will be 0, and 0 times I will make 0, of course, obviously. So that'll just leave us with a, which is a real number. But if b does not equal 0, then will be classified as a non-real complex number. Okay. But if a equals 0, leaving us with just bi, we will have a pure imaginary number. Because if we get rid of the real part in a complex number, then all we're left with is the imaginary part. So it'll be a pure imaginary part. Okay, we just talked about non-real complex numbers, real numbers, and pure imaginary numbers. Now, we'll go a little bit more in depth with it right here. This is a chart we have, and it shows us all the different forms of numbers. So first off, we have our natural numbers: 1, 2, 40, 87, numbers, whole numbers, 0, and all these fall into real numbers. We have integers, -1, -11, rational numbers like 4/9, -5/11, and we have irrational numbers, square root of 2, square root of 11. These are all real numbers. But other than real numbers, we have non-real numbers or complex numbers. Okay? And with real numbers, b will equal 0, so we won't have any imaginary part. But it's the opposite for complex numbers. So b cannot equal 0. So 7 plus 2i would be a non-real complex number. And inside non-real complex numbers, we have pure imaginary numbers. Like we just talked about, b cannot equal 0, but a will be 0. So it'll just be the imaginary part. 3i, -i squared root of 2, 100i, it'll just be completely imaginary. So now we'll solve for negative square roots. Or to solve for negative square roots, square root of -x will equal I square root of x. This is simple, okay? So when we have square roots, anything multiplied inside square root, okay, so square root of -x will essentially equal square root of x times square root of -1. And because we just factored square root of -1 out. And what does square root of -1 equal? That equals I. So it'll just simplify to I square root of x. Very simple. So I just told you how to solve square root of negative numbers. So now I will show you some actual examples. All right. So first up, let's think of a negative square root. So square root of -64, okay? So we know that square root of 64 is 8, but this is a negative, and -8 times -8 would also be 64, so we can't solve this. Like, a normal square root, we'll have to factor out I. So square root of 64 and square root of negative 1 is what this will factor into, or factor out to. And square root of negative 1 equals I. So it would be I square root of 64. Okay, now what did we just say square root of 64 could be? Square root of 64 can be 8. So this will equal 8 times I. Now let's move on to a harder problem. So square root of negative 98. Well, 98 doesn't have an actual whole square root number. So we'll have to simplify this one as best we can. So again, square root of 98, square root of negative 1 will be I square root of 98. Now let's make a factor tree for 98. So 98 will go down into 2 and 49. And 49 can be simplified into 7 and 7. So we have 2 of the same number, and now we can factor that out. So that'll be a 7I square root of 2. And that's as factored as much as we can. Simplest form. Moving on to an even harder problem, we will try out x squared plus 125. Okay? And this will equal 0. And now we have to solve for x. So we can subtract 125 from both sides, and that'll be x squared will equal negative 125. Okay, squaring, or if we do the square root, if we square root both sides, we can get x will equal square root of negative 125, or plus or minus square root of negative 125, okay? And then simplifying that square root inside, we will get plus or minus I square root of 125. And square root of 125 can be simplified like so. 5 times 25, and farther down we'll get 5 and 5. So we have a pair of 5s either way, and from this we can get x equals plus or minus 5I square root of 5. Okay, we'll be going even into further, more difficult equations, but before that, you have to know, before you can do anything with a radical, you must make it a positive. So, when multiplying or dividing or anything instead of a radical, so you cannot have the numbers inside be negative. You must first make them positive. So it has to be I square root of 21 times I square root of 12. You need to factor out the I before you proceed. So continuing with this equation of square root of negative 21 and square root of negative 12, which we already simplified to I square root of 21 times I square root of 12. If we multiply this together, all as one thing, we'd get I squared times, get our calculator for this, 21 times 12, that'll be square root of 252, and I squared would simplify to negative 1. But inside, we already know that 12 will break down into 3 and 4, and 21 will break down into 3 and 7. And that will also break, and the 4 will break down into 2 and 2. So now we have both a pair of 2's and a pair of 3's, okay? So we'll factor those out. 2 times 3 is 6. So this will be negative 1 times our 6 square root of 7, because it would have been I squared times 6. But since I squared became negative 1, we'll have negative 6 square root of 7 as our final answer. Okay, addition and subtraction with these equations is just as easy. So if we take two equations in standard form and add and subtract them, all we have to do is add and subtract their like terms. Okay, so negative 5 plus 8i will be our first standard one, minus 7 minus 9i. Simple enough, okay? So negative 5 minus 7, that'll be negative 12, and 8i minus negative 9i. So two negatives will make it addition. So 8i plus 9i will equal 17i. So plus 17i. That'll be our final answer. All we had to do is add the like terms. Multiplication, while a little bit trickier, we'll basically use a function you already know how to do. We'll be using FOIL. First, outside, inside, last. So we'll have two more equations in standard form, and for simplicity's sake, we'll use the same one as last time. Negative 5i plus 8i minus 7 minus 9i, and we'll just multiply using FOIL. First, so negative 5, wait, it wouldn't be minus, this will be multiplied because we're not doing subtraction. So negative 5 times 7, simple enough, that'll be negative 35. Outside, negative 5 times negative 9i, so that'll be plus 45i. So inside, 8i times 7, that'll be 56i plus 56i. So lastly, 8i times negative 9i. So that would be negative 72i minus I squared. Negative 72i squared. So I squared is negative 1, so it would be 72 times negative 1. But since it's also a negative, they'll cancel out and make it a positive 72. So we have negative 35 and a positive 72. So adding those together, we will get 37 as for a positive number or for a real number. And then we have 45 and 56 for imaginary numbers, and that will equal 101i. So this will be our final answer. All we have to do is use FOIL, and we will get our answer. Now, when multiplying these complex numbers, we may run into conjugates. So conjugate will just have a different sign in the middle, and the property of complex conjugates is very similar to the difference of two squares, which will be represented right here. So if these were multiplied by each other, they'd equal a plus b times a minus b would equal a squared minus b squared. Now the same can be said for our complex numbers, except we will have an I as a part of our b as well. So 3 plus 7i and 3 minus 7i. So this would equal 9. And if we were to FOIL it completely, we'd get minus, or first, outside, minus 21i plus 21i and negative 47i squared. Now, these cancel out, so we do have exactly this equation. So we have our 9, and we have our negative 49 I squared. And if we do simplify this I squared, it will equal negative 1, and negative 49 times negative 1 will equal 49. So 7 squared, or negative 7 squared, equals 49, and 3 squared equals 9. So add them together, and we will get 58. Final answer. Last thing we'll be going over is the different powers of I, okay? Now these are very simple, and all you have to do to solve these is multiply I by itself. So first off, we have normal I. That'll equal the square root of -1, right? And square root of -1 times square root of -1 is -1, okay? Now, I cubed would be the squared -1 times I. So this one could either be negative I or negative square root of -1. So cube, that'll be -1 times -1, 1. Okay, 5, so that'll be 1 times square root of -1, square root of -1, or the back to basic I. So it'll just repeat, -1, -I, and 1. Simple enough. Now, solving these is just as easy. So, say we have I of 25, or I to the 25th power. A little sloppy, but... So, we already know that 8 equals 1, so if we subtract an exponent of 8, it's still going to equal 1. So, 25 minus 8 will equal 17 minus 8, 9 minus 8, 1. So we have I to the first power, or I. So I to the 25th power is the same as I. Very simple.